Good morning. Today we are going to be starting Unit 6. This is Math with Business Applications. I really need to get a better opening. This is Math Business Applications. I am your instructor, Amy Fuchsteiner, and today we're going to start Unit 6. This is Chapter 10 in your textbook. We're going to be looking at simple interest and banknotes. Today we're going to begin with just understanding simple interest. So again, we're going to be starting Unit 6, Understanding Simple Interest. Chapter 10, this is our very first section, Section 1. Our goals for this particular section are as follows. We need to be sure that you have a good definition of interest, principal, interest rate, and maturity value. With that information, you need to be able to calculate simple interest using the principal, the annual interest rate, and time as a function of years, months, and days. And specifically, there are two different types when it comes to days, both ordinary interest and exact interest. We're going to need you to compare the amounts of simple interest that you get using ordinary interest and using exact interest. And then we want you to be able to calculate the days of the loan. This includes both the loan date and the due date for a loan. That means you're going to need your days of the year chart again, the one that we used for Chapter 7 when we were dating and doing terms of sale. So you'll need to pull that one back out. I'll make sure that there's a copy of it in the file for this week, so you should be able to have it there too. All right, and then we'll need to be able to calculate the maturity value of a loan. That is, once you know what it is, you're going to need to know how to calculate the maturity value, either from a flat-out formula that you're given or from understanding that maturity value is the principal plus the interest in a loan or an investment. So, what are some of these words that we may need to define or understand? Interest. Interest is the price that you pay for the privilege of using someone else's money. So when you take out a loan, you are using money from a bank or some other financial entity. And in order to get that loan, you have to have what's known as good credit. Now, this is not a personal finance course. We're not going to talk about how to get good credit, but good credit allows you entry into a world from which you can take money from other people and use it. When you return that money, you pay for the privilege of using someone else's money, and that payment is known as interest. You can earn interest yourself when someone uses your money. So when you make an investment, oftentimes when you invest in a CD or in a bank or you put it in a savings account, you're simply making your money available for someone else to use. And the bank or the financial service will then give you interest for making that money available. You pay the interest yourself when you use someone else's money. In all of these transactions, banks are the intermediary. They make money because of interest, because they charge interest when someone else uses money, and they give interest when you put your money into a savings account. But there's always a gap. They never give you as much interest as they've charged someone else. And that, my friends, is how the banks can make money. One of many ways. All right, so the parts that we need you to understand. The first is what principal is. Principal is what we call the sum of money that you're either putting in for the investment or that you're borrowing. So it's the initial amount of money that's either put into an account for savings or that's borrowed from someone else. The interest rate is the percentage, usually written as a decimal. When you see the word rate, it's almost always the percent in decimal form. So it is the percentage as a decimal that is charged yearly for the privilege of using somebody else's money. Now, When we say yearly, the problem is that time, while it is always based on a year, is often expressed in the terms of days, weeks, or months. So when you take out a loan, when a business in particular takes out a loan, they often take out loans for terms that, or for times that are less than a year. So they will sometimes talk about loans in terms of days, weeks, or months. Now, we need to go over this because it always amazes me, but it's true. Do you know how many days are in a year? There are 365 days in a year. For some banks, or for the banker's rule, they use the number 360. I'll go into why that is a little bit later. Just to be clear, there are 52 weeks in a year. We've been talking about this as we talk about weekly paychecks and all the rest. There are 52 weeks in a year, and there are 12 months. These numbers are important because time and your interest rate is based on a year, but we don't always count. We don't always just take out loans for a full year, okay? All right, so the interest that we're going to talk about in this section is simple interest. Simple interest is called simple interest because it is only calculated one time. Now, how do we calculate simple interest? Simple interest has a formula. It's I is equal to PRT. This is your formula for simple interest. I stands for the interest. P stands for principal, the money, again, that is invested or borrowed. R is your interest rate. This, again, is a yearly rate. It is the percentage charged by the banks or given to you by the banks, and it is generally written as a decimal when we complete this formula. T is time. Time is based in years, so if they give you months, we divide out by 12. If they give you days, we divide out by either 365, that's known as exact interest, or 360, that's ordinary interest. If they give you weeks, that is out of 52. As a reminder, it is called simple interest because it is only calculated one time for the entire period of the loan. We only calculate interest once. Now, little bit of an aside. This is not the way most of us, on a personal level, borrow money. In other words, when I bought my car, I had to borrow money to purchase my new vehicle. I did not get a loan that allowed me to keep and drive the car for 5 years and then only pay at the end. Simple interest loan would have said, okay, I'm going to borrow $16,000 and I'm going to drive the car around for 5 years. And then at the end of 5 years, I'm going to give you $16,000 plus another $4,000. So I'll give you $20,000 at the end of 5 years. Personally, the world does not work on a simple interest loan, which is why simple interest loans are generally done between businesses for short periods, like less than a year, right? I can take out a loan for 3 months and it might be simple interest because that particular payment then is only waiting 3 months. We do not use simple interest loans for long-term functions like mortgages or car loans or even vacation loans. We don't. There's just no guarantee that people will fulfill things at the end of the loan. So, all right. Moving on, if it'll come off of this slide. There we go. All right, so let's try a couple of problems. What is the interest on a loan of $18,000 for 5 years at 8%? And as I stated earlier, this would not be a simple interest loan in general, but we're going to practice as if it can be. So we know that interest is equal to the principal times the rate times the time. We are going to simplify this as I equal PRT. P is for principal, R is for rate, T is for time in years. Now, we know our principal is the amount of the loan, that's $18,000. Our rate is 8%. As a decimal, this would be 0.08. and our T is time in years, and they gave us a flat 5 years. So this will be 18,000 times 0.08 times 5. Principal times rate times time. If I multiply this out, I get 7,200, meaning the interest on this particular loan is $7,200. Now, the total repayment. The total repayment is all of the principal, so all that was initially borrowed, plus any interest. Since my principal was $18,000 and the interest was $7,200, the repayment will be both of those amounts. So the repayment would be $25,200. Okay, trying a second one. What is the amount of interest on a loan of $800 at 18% interest for 7 months? Now, this one is a little bit better because we're only talking about 7 months, which is less than a year. So this is a little bit more grounded in reality for a simple interest loan. We know that our interest is the principal times the rate times the time, or I is equal to PRT. Our principal is the $800. Our rate is the 18%. As a decimal, this would be 0.18, and our time is 7 months. Now remember, time is based on a year, so that 7 months would be out of the 12 months in a year. I'm keeping both of them in the month arena, right? 7 months, so I'm comparing it to 12 months in a year. In the formula, we would then write this as 7 over 12. Now, when I type it into my calculator, I'm just going to do it as 800 times 0.18 times 7 divided by 12. If you have a fraction button on your calculator and you know how to use it, you can do 800 times 0.18 times, and then fraction button 7, 12, and then hit enter, okay? Either way, this works out to be an interest of $84. And I have found the amount of interest to be just $84. It kind of makes sense. It's a short amount of time, so the interest should be a smaller amount. The less time you have in an investment or in a loan, the less interest you end up paying, whether that's simple interest or compound, which we'll be doing later. All right, our total repayment is, again, the amount of the loan and the interest on the loan. So this would be 800 plus 84, which is 884. That was not a tough add for me. Okay, now on this slide, I also have just a full-on chart of simple interest practice. I am not going to say anything through this, but I am going to click through it. So if you want to, you can skip a minute or so ahead as I do that. But if not, you may just want to keep that pause button available and just pause, practice, just to make sure that you've got all of the pieces of this, all right? So here I'm going to silently click through. All right, so far when we've talked about time, we've done an example of time measured in years, and we've done an example of time measured in months. So what I want to talk about right now is time measured in days. So there are 365 days in a year, except to most banks. All right. If we do 365 days in a year, that's known as exact interest. The interesting part for me here is that it needs to say exact interest. If they don't say they're using exact interest, then we assume ordinary. Now, sometimes it'll say ordinary, sometimes it won't, but ordinary is our default. If you cannot find that it says exact interest and they're talking about days, you assume it's ordinary. Ordinary interest says that there are 360 days in a year. There aren't. There are 365. Why do they use 360? Well, I initially thought when I first started teaching this course that it was likely because if you discounted Christmas and Thanksgiving and the 4th of July and Easter and then like Memorial Day, I figured there were 5 holidays that the banks took off, like 5 days where the banks would be closed. Maybe initially when banks first opened, there were 5 major holidays for which they closed. I wasn't thinking like a mathematician. So basically what happens is, remember that when banks first started, say, I don't know when banks first started, 1800s, right? Wells Fargo, Pony Express, okay. They had to do all of these by hand. All of these calculations had to be like written out and done on an abacus. If you don't know what an abacus is, that's fine. So 365, there's not a lot of numbers that divide evenly by 365. In other words, 365 does not have a lot of factors. 365 is divisible by 5. And like, not even. It's not divisible by 2. It's not divisible by 3. It's not divisible by 4. It's divisible by 5. 365 is not divisible by 6. It's not divisible by 7. It's not divisible by 8 or 9 or 10. None of these numbers go into 365. But 360. 360 is divisible by 2. It is divisible by 3. It is divisible by 4, by 5, by 6, not by 7, by 8, by 9, by 10. So as a mathematician, I got to say they used 360 because it was just easier. Lots of stuff went into 360. They had options with 360 that they did not have with 365. And thus they started using 360, and then that became what's known as the banker's rule for the number of days in a year. Now, what if you're given time in days? If you're given a problem with the time in days, you have to first look at the problem and say, does it say exact? Because if it says exact, then I have to use 365. If it doesn't say exact, there are 2 options. First, that it says it's simple ordinary interest, and that means you're using 360. The second option is it doesn't say anything. It just says a loan of 20 days, right? So which one do you use? Well, the default is 360. If it doesn't say, if you're unclear, we want you to use 360, okay? Then you take the number of days in that loan and you divide it by the days in the year. It's exact. If it's exact, you're using 365. And if it's ordinary or not stated, then you're using 360. Let's try a couple problems. This one says, using the exact interest method, what is the amount of interest on a loan of $4,000 at 7% interest for 80 days? Notice that it does say exact interest method. Since interest is equal to principal times rate times time, or I is equal to PRT, and we can see that time is going to be exact interest, or 365 days in a year. So the 80 days that they've given us is going to be out of 365. And I will have 4,000 times 0.07 times 80 divided by 365. Working this out on the calculator, I get 61.36986,301. These are dollars and cents. So we're rounding to the hundredths place, which means I'm looking at the 6 in 0.36. To the right of that, I have a 9, so it's going to round the 6 up and I have $61.37. We're going to do this problem again and recalculate it, this time using ordinary interest. Now, by the way, I don't think I told you the trick in the last slide. So here's my trick for remembering that exact is 365. That's because there's 365 days in a year. And ordinary is 360. One of the other things I also do is that the O in ordinary is the 0 in 360. And if I make that connection in my brain, I have a little bit less of a chance of goofing that one up. Just an option. All right, so same basic formula. Interest is principal times rate times time, or I is equal to PRT. This time, if time is based on an ordinary interest, then we use 360 days in a year, not 630. Oh man, how did I turn those numbers around? Okay, I'll have to fix that, repost. Not going to repost the video. I'll repost the PowerPoint. All right, so our formula then would be written as 80 out of 360. So I'd have 4,000 times 0.07 times 80 out of 360, or 62.2 repeating. Rounding to the nearest hundredths, so I have dollars and cents. This is $62.22. Notice for a moment, which one is more? Which one gets more interest? It's not a lot more, but it's more. All right, so Karen's going to borrow $4,500, $45,000, sorry, for 100 days at 8 3/4%. If the bank uses ordinary interest method, how much interest will Karen have to pay? So we're going to be doing the ordinary interest method. Ordinary interest, remember, is 360 days. So interest is principal times rate times time, where I is equal to PRT. Then I have 45,000 times 0.0875 times 100 over 360. This works out to be $1,093.75. No need to round. It was already dollars and cents. I'm going to recalculate this using exact interest. And when I use exact interest, I have to remember that that is 365. So interest is principal times rate times time, or I is equal to PRT, where I have a principal of $45,000, an interest rate of 8.75%, so 0.0875 as a decimal. And then my time would be 100 days out of 365. And when I multiply that through, I get $1,078, and rounding to the nearest penny, I get 77 cents. And again, which one is more? Of the two interests, the ordinary, which was the first one, and the exact, which was the second, which one gave the bank more interest? The next slide is again practice. This is available in the PowerPoint, but once again, I'm going to just sit in silence and click through this. Feel free to use that pause button to practice. Did you get those? Nice job. Those ones, I'm not sure if they were tougher than the last ones or not. Now, looking at the two columns, compare the exact interest totals, or answers, I guess I should say, to the ordinary interest answers. Hopefully you've noticed that the exact interest is always less than the ordinary interest. The ordinary interest is always slightly higher than the exact interest. Now, I know I told you all about the way more options with ordinary interest at 360 days, and it has more divisors and more numbers go into it, and that makes it better and easier and all of that. But long story short, when it came right down to it, the banks make more money with ordinary interest. And since they make more money with ordinary interest, why would they ever switch to exact? One of the last things we have to talk about today, at least, is maturity value. Maturity value is just what we call the total repayment. That is the principal plus the interest. We've done it already here along the slide. We've called it the total repayment. We have simply added the principal and the interest together. There are two ways to determine the maturity value. The first one we've done. Maturity value is the principal amount plus the interest. Now, I'm going to show you some algebra. So tune in, zone out, whichever. We know maturity value is the principal plus the interest. We also know that interest is principal times rate times time. So if I swap out the I in interest for principal times rate times time, I'm giving you the name of interest in just a different way, right? I've put the formula for interest in there. Do you see how in those two, both of them have a P? There's a P in that first term, and there's a P in that second term. So I am going to pull that P out front, undistribute it from both of those terms, and then I'm left with 1 plus RT. So I have that the maturity value is the principal times 1 plus the rate times time. This is the formula for maturity value. You can use either option. I tend to think of it this way. If in the problem they're going to ask me about the interest, if I have to answer them what is the interest, just straight interest, then I'm going to use option number 1 because I need to know the maturity value and the interest. So I might as well use option number 1. If they just ask me for the maturity value, just straight up, what is the maturity value? I'm not going to find the interest first. I don't have to. I'm, for efficiency's sake, just going to go to the formula. Now, in reality, if you want to always find the interest and add it onto the principal, you are welcome to do so. There is absolutely nothing that says you have to use the formula ever. A problem to try, I'm going to do it both ways in this particular instance. What is the maturity value on a loan of $15,000 borrowed at 13% interest for 28 months? So in the first example, I'm going to add the interest to the principal. So maturity value is principal plus the interest. I know interest is principal times rate times time, or principal of 15,000 times 0.13, that's 13% as a decimal, for 28 months. And since it's months, it's going to be 28 out of 12 months in a year. Multiplying this through, I get $4,550. So since the maturity value is the principal plus the interest, I now have to take the $15,000 and add that $4,550 to get $19,550. If I'm doing the maturity value formula, the maturity value is principal times 1 plus the rate times time. This will be 15,000 times in parentheses 1 plus 0.13 times 28 over 12. Close those parentheses again. So I do need a double set of parentheses here. Or 15,000 times 1.303 repeating to get 19,550. In either case, I get 19,550 as my answer. Those of you who are very familiar with your calculators will like the formula better. Those of you who are not as familiar will probably find the interest and then add it to the principal. Both are fine. All right, how do we calculate the days in a loan? Well, we have to all agree that the loan date is the first day of the loan, and the due date is what we're going to call the last day of the loan. In order to figure out the number of days in the loan, you will probably want your days in a year chart, and then all we're going to be doing is subtracting. So your dating chart, if you recall, I think I've got it just here to my left. Yeah, it'll be in the file. So here we go. Ryan's going to borrow $80,000 on June 15th at 11% exact interest. The loan is due on August 9th. Find the interest and the maturity value. All right, so to find the interest, that was our first thing here. We know interest is principal times rate times time. I equals PRT. So that's 80,000 times 11% times the days. The days, it's exact interest, so I know those days will be out of 365, but I don't know what those days are. I know the loan date is June 15th, and I know the due date is August 9th. So on my dating chart, I'm going to look up June 15th, and I'm going to find that that's day 166. I'm going to look up August 9th and see that that's day 221. In order to find the number of days in the loan, I'm just going to subtract 221 minus 166, and that's going to give me 55 days in this loan. So now I can do 80,000 times 11%, 0.11, times 55 out of 365, which works out to be $1,326.03. Woohoo! Now, to find the maturity value, I've already found the interest. So I'm just going to add the interest to the principal. So 80,000 times $1,326.03 gives me a maturity value of $81,326.03. Second example, Kylie is going to invest $22,000 on April 7th at 2.5% simple interest. The investment comes due on November 3rd. Determine the maturity value of this investment. Two things. They said simple interest. They did not tell me if it was ordinary or exact. Since time is days of April 7th and November 3rd, I'm going to assume that they mean ordinary because that's our default position. We're going to go to ordinary. And they want just the maturity value. So in this example, I'm not going to figure out interest first. You certainly could if you wanted to. So jumping to the maturity value, we know the maturity value is the principal times 1 plus the rate times time. Putting in the numbers I have, my principal is 22,000. My rate is 0.025. The time is days out of 360. I don't know how many days. I know the loan date is April 7th. I know the due date is November 3rd. The difference between those two is the number of days in the loan. So looking up my dating chart, I see that April 7th is day 97 and that November 3rd is day 307. Subtracting those, 307 minus 97, I get 210. So that will go where the word days is. 22,000 times 1 plus 0.025 times 210 over 360 gets me $22,320.83. So my maturity value is $22,320.83. All right, how do we determine the maturity date? Method number 1, there are actually 2 different methods. The first uses the days in a year chart. So this chart comes back at us again. If you're really comfortable With the days in a year, you may also find that you can count the days using your knuckles or that nursery rhyme, 31 days or 30 days have September, April, June, and November. So these are two different methods for using them. I use the days in a year chart on this one. I got pretty good at dating from chapter 7, but for this one, I have to use the days in the year. All right, on October 20th, Jake takes out $9,000 at 9.4 ordinary interest for 90 days. Determine the loan's maturity date and the maturity value of this loan. So I'm going to see if I can find the maturity date first. We know the loan date was October 20th, and we know that we will need the dating chart to go 90 days forward. So October 20th, if I look at the chart, is day 293. Since the loan is 90 days from that, I'm going to add 293 to 90, and I get 383. The chart doesn't go up to 383. There are only 365 days in a year. So I have to take the 383 and subtract 365. That gives me 18. Day 18, based on this chart, is my maturity date or the due date of the loan, and that's going to be January 18th. The maturity value, since it didn't ask me for just interest, I'm going to use just the maturity value formula, P times 1 plus RT, my principal being 9,000, 1 plus 0.094, because it was 9.4 ordinary interest, and 90 days out of 360, which gets me $9,211.50. So the maturity value would be $9,211.50. Once again, I have a lovely chart to click through. So the first problem gives us September 5th as the loan date, and the due date is September 12th. Going on to the chart and looking up both of those and subtracting them, we find that that should leave you 98 days for the loan. If our loan starts on June 20th and we have 215 days in the loan, that should bring you to January the 21st. The next two are very similar. And these last two are a little bit harder, because if the due date is September 20th and I know the number of days in the loan is 21, I want to find the date of September 20th and not add, but subtract the number of days. So I'd find September 20th, what day is that? And I'd subtract 21 to get. And for January 29th, with 80 days in the loan, I know that January 29th is the end. So normally I would subtract 80, but in terms of days in the year, I don't have enough. So there's two sort of things you can do here. One of the first is to go into negatives. You're not going to be very comfortable with that, maybe. But the second is to go ahead and find the day for January 29th. How many days is that? 29. And then add that to 365. So when you subtract, you're going backwards into the previous year. That will work as well. That was the last bit for this particular section. So let's just go over the set of goals and make sure that you feel confident doing all of these things. Do you feel like you could define or explain interest, principal, interest rate, and maturity value? Are you comfortable calculating simple interest if given principal, interest rate, and time in any of the formats? Did you catch the part where we compared simple interest, ordinary, and exact? And did you catch the conclusion there? Can you calculate the number of days in a loan if given the loan date and the due date? And can you find the maturity value on a loan using either the formula or the principal and interest? Either one. So In your e-text, Chapter 10, Section 1, there are review exercises at the end. This is only extra practice. It is not a requirement. If you have the physical copy of the book, you will find this extra practice on pages 270 to 273, I believe. There is a graded assignment. It is located on WebAssign, and it is creatively titled Chapter 10, Section 1. As always, if you have any questions, don't hesitate to reach out to your instructor, to our embedded math support, reach out to the Math Center, or any other tutors you have available to you. We all want you to do well, and we're here to help. Thanks. Hello again. I know I promised several times, but I didn't deliver. So this is Miko. I have 2 foster puppies, but now I just have Miko. Hello, Miko. Say hello to everybody. Oh, he's not very happy with me. He was sleeping at my feet the entire video. But, he's gonna eat my finger. Oh, I promised, and now I have delivered. Just gonna give you another 30 seconds of me and the puppers. I guess my gnomes are going to have a little less beard. Thank you.